Dance DJ.
Continuity. The word continuity is used to indicate the absence of any break or gap in the graph of a function. Let us compare two informant graphs. Look at this graph. The line is connected between the start and the end without any break. This type of graph is called a continuous graph. Look at this second graph. When we draw the line starting here, the line is ended here, another line starting here. These two lines are not connected with each other. There is a break between the lines. This type of graph is called a discontinuity graph. Limits. This notation or symbol we can read as x tends to a or x approaches to a. Let us consider a number line and a constant value a is on the line. If x approaches from value less than a, that is from left side of a, we consider as left hand limit and written as left hand limit is written like this. Limit x tends to a from left side function of x, and if the value of x approaches from the value is greater than a, that is from right side of a, we consider as right hand limit. Right hand limit is written like this. Limit x tends to a positive sign is assigned here, function of x. X approach to 2 means the value of x is nearby or close to 2, that is x does not equal to 2. Continuity of a function at a point. A function f(x) is said to be continuous at a point x equal to a if f of a exists. Second condition, limit x tends to a, f of x exists. And number 3, limit x tends to a, f of x is equal to fa. exercise 5.1. Question number 1. Prove that the function f of x is equal to 5x minus 3 is continuous at x equal to 0, at x equal to minus 3, and at x equal to 5. Let us check at three different values when x equal to 1, x equal to minus 3, and at x equal to 5. Solution. Given function fx is equal to 5x minus 3. Let us check continuity at x equal to 0. Continuity at x equal to 0. Applying limit x tends to here x tends to 0, so x tends to 0. F of x equal to limit x tends to 0. Here fx, this fx is equal to 5x minus 3. So instead of writing f of x, we have to put 5x minus 3. Now substitute the value of x equal to 0. 5, the value of x here is equal to 0. So let us substitute the value of x equal to 0 minus 3. 5 0 is 0. Now minus 3. Again, let us put the values of f of x. The value of x here 0. Instead of writing x, we have to put 0 here. F of x equal to f of 0. Here 5 x, the value of x is substituting 0 minus 3, that is minus 3. As limit x tends to 0, f of x, limit x tends to 0, f of x is also minus 3, and it is equal to limit f of x. F of x is also, its value is minus 3. So limit f of x is equal to f of x. Therefore fx is continuous at x equal to 0. Let us check continuity at x equal to minus 3. Limit x approach to minus 3, f of x equal to limit x tends to minus 3, f of x here 5x minus 3. Substituting the values of x equal to minus 3. 5x is minus 3 minus 3 equal to 5 3 are 15, minus sign is there, so minus 15 minus 3 minus minus, that means same sign adding each other, so minus 18. And f of x, values of x is minus 3. Then let us substitute the values of x equal to minus 3. 5 minus 3 minus 3. 5 3 are 15, minus 15 minus 3, that is it is equal to minus 18. As limit x tends to 3 minus 3, f of x equal to f of x. Therefore limit is continuous at fx is continuous at x equal to minus 3. Continuity at x equal to 5. Limit x tends to 5, f of x equal to limit x tends to 5, fx is 5x minus 3. Let us substitute the values of x equal to minus 5. Now we get 5 minus 3, that is 5 5 are 25 minus 3, that is positive 22. And f of x, that is 5, equal to, substitute the value of fx equal to 5, we get 5 minus 3, that is 5 5 are 25 minus 3 equal to 22. Therefore limit x tends to 5, f of x is equal to f of x. So f of x is continuous at x equal to 5. Question number 2. Examine the continuity of the function fx equal to twice x squared minus 1 at x equal to 3. Let's check continuity of this function at x equal to 3. Solution. Given function fx is equal to twice x squared minus 1. Check continuity at x equal to 3. Applying the limit x approaches 3, f of x equal to limit x approaches to 3, f of x here twice x squared minus 1, twice x squared minus 1. Substituting the value of x equal to 3, we get 2, value of x is here 3 squared minus 1, 2 3 squared, 3 3 are 9, 2 into 9 minus 1 is equal to 2 9 are 18, 18 minus 1 is 18 minus 1 is 17 and f of x is 3. To substituting the values of x equal to 3 square minus 1, 3 square is 9, 9 2 are 18, 18 minus 1, that is equal to 17. Therefore, limit of x tends to 3, f of x is equal to f of x. So fx is continuous at x equal to 3.